Hello Math 1. This video is on 9.a, which is I can determine if an ordered pair is a solution to a system. Now, before we can go into the concept here, we have to know what a system of equations is. And a system of equations is basically two or more equations with two or more variables. Okay? Now, with this, a solution to a system is an ordered pair. And remember, anytime we talk ordered pair, we're talking x comma y, like a point in the coordinate plane that makes, right, both, right, or if there's more than two equations, all of the equations true. Okay, so it's important to know that you have two or more equations with two or more variables. And the solution to this system is going to be the ordered pair xy that makes both or all of the equations true. Now, the easiest way to check to see if an ordered pair is a solution, to check if it is a solution, all you are going to do is take this ordered pair, right? Which in this case, your two variables in the equation are x and y. So here's your x value, here's your y value. And all you're going to do is substitute those values back into each of the equations. If the ordered pair makes both equations true, it's a solution. If it only makes one equation true, it's not a solution. Okay, so let's take a look here. If I go ahead and I say, in this ordered pair, x is 1 and y is 4. I'm going to replace y with 4 equals 1 plus 3. Is that going to be a true statement? Yes, that checks out. How about the next one? Replace y with 4 equals 8 times 1 minus 4. 4 equals 8 minus 4, which is 4. That checks out. Therefore, 1, 4 is a solution. Okay, when we look at the next one, okay, now our ordered pair is 4, negative 1. So we know x is 4, y is negative 1. So we're basically going to substitute this in. So when I go to substitute it in, 3 times x is 4, right? Minus 2 times negative 1. Does that equal 14? Well, now guys, you should always know order of operations multiply. So this gives you 12, and then negative 2 times negative 1 is positive 2, and 12 plus 2 is 14, which means this checks out. Now, if you don't, guys, just plug this in the way you see it on your paper on your calculator. 3 times 4 minus 2 times negative 1. Hit enter. What does the left side give you? 14. So if I want to do the second one this way, 6 times 4 plus y is negative 1 equals 8. So I go over to my calculator. 6 times 4, right? Plus, in parentheses, negative 1, right, gives me 23. Is 23 equal to 8? No, that does not work. So 4, negative 1 is not a solution. Okay? Check the next one. Now, in this ordered pair, x is negative 7, y is 5, right? So I'm going to plug that in. So 4 times negative 7 minus 7 times 5, will that equal negative 63? Well, I'll go to my calculator. 4 times negative 7 minus 7 times 5 equals negative 63. So this one checks out. That's good. So now, is 13 times negative 7 plus 7 times 5, will that equal negative 56? 13 times negative 7 plus 7 times 5, hit enter, get negative 56. Does negative 56 equal negative 56? Yes. Therefore, negative 7, 5 is a solution. Now, when I get to an example like number 4, determine which ordered pair, which ordered pair is a solution to the system. Guys, all I'm going to do is plug these in. I'll always start with the first equation. If that one's false, it can't be a solution. So right away, I'm just going to do, right? I know I'm going to substitute 835 into that. So it's 27 times 8 minus 4 times 35. Does that equal 76? So that the first one checks out, right? Now we'll check the next one. Does 9 times 8 plus 4 times 35, will that equal 68? No. Therefore, that is not a solution. Next one, 27 times 4 minus 4 times 8. Does that equal 76? That checks out. How about 9 times 4 plus 4 times 8? That equals 68. Does that check out? Yes. So letter B is your solution. You'll know right away. If I have a system of linear equations, because these are lines, okay, lines will only intersect one time, which means there will only be one solution to a system of linear equations. So just keep that in mind. All right, go ahead, try problems on your own and let us know if you have questions.